Hi everyone. Okay, today is going to be lesson 20, which is adding fractions, session 2, and it starts on page 417. Okay, so today is just adding fractions, not both, not adding and subtracting, just adding. Okay, so this blue problem right here, this is the problem that normally we would read it out loud. We would do the 3 reads problems, and then we would get a chance to try it ourselves. So after I read it, if you want to pause the video and try to solve it on your own and then replay the video to check your answer, that would be great. That would be similar to what we would do if we were together in class, okay? So let's read it out. Josie and Margot are painting a fence green. Josie starts at one end and paints 3/10 of the fence. Margot starts at the other end and paints 4/10 of it. What fraction of the fence do they paint all together? Okay, so I told you we're adding fractions, but the word all together should also give you a hint that we are adding those two fractions together, okay? So there's a couple different ways you could do this. You could just start right off the bat with an equation, or you could draw a picture or like a model of it first, okay? So if you want to pause it and try it yourself, definitely do that. But if you are ready to check your answer, I'm going to start with a model. Okay, so here's my fence. Okay, and it's going to be like on the side over here, these like boards for the fence, right? So it needs to be tenths. So I need 5 on one side. There's 5, that's super even. Nice job, me. 2, 3, 4, 5, not bad. Okay, there's my fence. 10 total pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, 10 equal parts. Okay, because that's my denominator. And then Josie starts on one end and paints 3/10. So Josie starts over here and she does 3/10. So I will shade in 1, 2, 3. And then it says Margot starts on the other end. So they're painting like towards each other, okay? And she paints 4/10 of it. So, and I don't have a green highlighter, otherwise I would use that because they're painting the fence green. Blue will have to work. So she does 4/10, so that's 4 of it. So Josie did 3/10, Margot did 4/10. What fraction of the fence do they paint all together? So how many boards or how many tenths together did they do? So then you could hop over and start your equation. Okay, so I know my denominator will not change. It's still going to be 10 equal parts. Then how many did I color in blue? Or how many did they paint green, right? 3 plus 4 equals 7. 1, 2, 3, 4, 5, 6, 7. 7/10. That's how much of the fence they painted together. So how much of the fence do they still have to paint? That's not part of the question, but just wondering if you know. They would have 3/10 left to go, right? Because 10/10 minus the 7/10 they've already done is 3/10. Okay, so that's your answer. If you want to write it in a sentence, they have painted 7/10 of the fence. Ta-da! Back page, and we'll answer some questions about it. Okay, so on this page is where they show us the strategies that they would like us to use for this problem. So they did a picture, which is like my model. I just didn't draw like the little pointed tops of the boards, right? But here's the 3/10 that Josie painted, and here's the 4/10 that Margot painted. So that's the same as our drawing, our model. Or you could have done a number line. They did a number line here on the bottom with tenths. So they showed the 3/10 and then they hopped up the number line. They added 4/10 more and ended at 7/10. Okay? All right, so connected questions. Okay, I like the green paintbrush over here, that's cool. Number 1, look at picture it. So that's talking about their models they just did over here. How do you know that each section of fence is 1/10 of the whole fence? Okay, well, how do we know that one board is 1/10 of the entire fence? The denominator of the fraction is 10, so that would be how many equal parts there are, right? There are 10 equal parts in the fence. So one section is 1 out of 10, 1/10, right? Okay. Number 2, what do the numerators 3 and 4 tell you? So like Josie's section was 3/10 and Margot's section was 4/10. So what do the numerators tell you? Like in the problem, if you relate that back to the problem, what is 3 and what is 4? Okay, so 3 is the number of boards, or the number of sections Josie paints. Okay, see, like we're relating it back to the problem. So what does the 3 mean? What does the 4 tell us? So 4 would be the number of sections that Margot painted right here. 4 is the number of sections Margot paints. Okay. Number 3. How many tenths of the fence do Josie and Margot paint all together? So how many sections did they paint together? That would be 7. That's how many tenths they painted together. So complete the equation. 3/10 plus 4/10 equals 7/10. And then if we do that with fractions, 3/10 plus 4/10 equals 7/10. Okay. Number 5, what would be the sum if the fractions were 3/10 and 5/10? So they're saying if you added those, because sum, remember, is the answer of an addition equation. 3/10 plus 5/10. So denominator stays the same. 3 plus 5 is 8. Explain how you add fractions that have the same denominator. Okay, so if you want to pause and do this in your own words, you definitely can, or if you want to word it differently than I'm about to, go for it. I'm just going to say you add the numerators. But do not add the denominators. Right, that's the rule. That's what we should have been doing from the start. That's what I've been saying since lesson 19, session 1. Okay, so reflect. Which strategy do you like best for adding fractions? So there's a couple different options. You could do a model, like a picture, a number line, equation. What's your favorite strategy, okay? So do that down there, and then turn the page. You got a couple problems to try these strategies out on. So after you've reflected, we've got this page to work on. So number 8. Let's see, you're zoomed in pretty well. Okay. Lita and Otis help their mom clean the house. Lita cleans 1/3 of the house. Otis cleans 1/3 of the house. What fraction of the house do Lita and Otis clean all together? Show your work. So Lita cleans 1/3, Otis cleans 1/3. So I could draw a model to show my work. So this is their whole house. It's going to be in thirds, so there's going to be 3 total parts. Lita cleans 1/3 of it. And if I grab another color, Otis cleans another third. So together, all together, how much did they clean? 1/3 plus 1/3. Okay, I could do that in a fraction, or in an equation, I mean, with fractions. 1/3 plus 1/3. Denominator stays the same. Add the numerators. 1 plus 1 equals 2. So together they clean 2/3 of the house. They cleaned 2/3 of the house. Okay, so you can see that in your model. 2/3 is colored in, that's the part that's cleaned. Or you can see that in your equation. Lita cleaned this much, Otis cleaned this much, together they cleaned this much. 1 star for showing your work, 1 star for your solution in a sentence. Number 9. Mark and Imani use string for a project. Mark's string is 1/5 of a meter long. Imani's string is 3/5 of a meter long. How long are the 2 strings combined? Show your work. Okay, I'm just gonna go straight to an equation for these ones because that's gonna be probably your quickest way. Showing a model is great, you know, if they ask you to, but I'm assuming you guys are all comfortable with adding fractions like this because remember, you keep the denominator the same, you just add the numerator. 1 plus 1, we can do that, okay? In this case though, Mark's string is 1/5, Imani's string is 3/5. Still, just as E-word as this one up here. Denominator stays the same, 5 all the way across. 1 plus 3 equals 4. Okay, so how long are the 2 strings combined? 4/5 of a meter. Star for 4/5, star for showing your work. If you did a model or a number line or another way to show your work, that's fine too, and you can have a star for your work as long as you ended up with that sum. Okay, and number 10, last one here on the bottom. Paula makes a fruit smoothie. She uses 2/8 of a pound of strawberries and 4/8 of a pound of blueberries. How many pounds of fruit does she use? Show your work. So 2/8 of a pound of strawberries, so 2/8 pound strawberries plus 4/8 pound blueberries. Strawberries plus blueberries equals how much total fruit? Okay, what fraction of a pound of fruit? So denominator stays the same. 2 plus 4 equals 6. So she uses 6/8 of a pound of fruit. Star for showing your work, star for your answer in a sentence. Okay, those are fast. If you need to pause and catch up at any point, you have that ability. Pause the video, catch up, show your work nicely. It should just be pretty quick, right? Just a pretty simple equation. Simple is a synonym for easy, sorry. If anyone is having trouble with this, comment down below. I can do another video, I can break it down more if you need to, but I'm assuming you guys are doing okay with this because really, keeping the denominator the same and then you're just adding a 1-digit number plus a 1-digit number to get the numerator. Okay, and we're all comfortable with drawing models like that. Okay, next page is the practice page. Okay, so the example up at the top is a muffin pan. It holds 12 muffins total. Sharina fills 3/12 of the pan with carrot muffin batter. Gross. She fills 6/12 with pumpkin muffin batter. What fraction of the pan does she fill? So together, how many 12ths is that? Well, 3 plus 6 is 9, so 9/12. Ta-da! Okay. Number 1. Oh, more muffins. Okay. Sam fills 2/12 of another pan with banana muffin batter. Shade 2/12 of the muffin pan diagram at the right. Okay, well, any two of those circles, right? If this is the muffin pan, you're looking down on it like in this picture, any two. Doesn't have to be these two, any two of them, okay? Star if you colored two circles. We're back in kindergarten, coloring in circles. Okay, number 2. Then Sam fills 6/12 with lemon muffin batter. Shade 6/12 of the diagram to show this. Okay, now we need to color in an additional 6 circles. 1, 2, 3, 4, 5, 6. Okay, so my purple circles, my 2 purple ones are the banana muffin, and the 6 red ones are the lemon muffin batter. So star if you colored in 6 more circles. Number 3, in problem 2, what fraction of the pan is filled now? So total, what's the fraction that's colored in? Either color. Okay, 1, 2, 3, 4, 5, 6, 7, 8. 8 out of how many total? 12. Write an equation for this problem that includes your answer. So we need to write an equation and solve it. So there was 2/12 of the pan was banana muffins right here. And then 6/12 were the lemon muffins, the 6 red ones. If we add that together, denominator stays the same. 2 plus 6 equals 8. Look, our answer is right there. Ta-da! Back page. Who's feeling good about adding fractions? I like it. I think it's fun. Fun may not be the best word. Okay, number 4. Oh, I guess there's a problem above it. Kay runs 6/8 of a mile and rests. Then she runs another 6/8 of a mile. Divide the number line below to show eighths. Okay, so this is sometimes tricky for people because this is one whole right there. Okay, so if we're showing eighths, like the denominator 8, right here at 1 is going to be 8/8. That is a thing that some people do not get. One whole equals 8/8. If I had a pizza and it was cut into 8 sections and I ate all 8 of them, I would eat one whole pizza. Okay. What about 2 whole pizzas? That would be 16/8. All right, so I need to show from 0/8 to 8/8 right here. So to make it even, I'm going to cut it in half, and that'll be my 4/8 because halfway, that's equivalent to half if it's 8 as the denominator. And half again, and that'll be 2/8, 6/8. Okay, then I can have 1 in between each. There's 1/8, 3/8, 5/8, and 7/8. And then one whole is 8/8. Okay. Now I need the same thing over here. Between 1 and 2, if I cut that in half. And then halfway between 6 and 8 is 12/8. So 9, 10, 11, 12, 13, 14, 15, 16. Okay. 9/8, 10/8, 11/8, there's 12/8, 13/8, 14/8, and 15/8. Okay, I feel like they should not have drawn these feet here, and they should have extended this longer so it was a little neater because that was tricky. Okay, we divided it to show eighths. Get a star if you did this with me. Pause it if you need to catch up. Label 6/8 on the number line above. Okay, 6/8. Right there. I'm just going to put a dot on the number line where that's at. Done. Use arrows to show 6/8 plus 6/8 on the number line. Okay, so I would start at 0 and go up to 6/8 and then 6/8 more. Okay, so I'm going to go up 6 more. That means I need to end on 12. Because 6 plus 6 equals 12/8. So what's the total distance K runs? That would be 12/8 of a mile. We did the arrows, 12/8 of a mile. Write an equation for this problem that includes your answer. Okay, so 6/8 before she rests, 6/8 after she rests is a total of 12 because 6 plus 6 equals 12 and the denominator stays the same. Done. Okay, now number 9 is a totally new problem, not about Kay and her running. New problem. Okay, Jin cleans 1/10 of the patio before lunch and 9/10 of the patio after lunch. What fraction of the patio does Jin clean altogether? Show your work. Okay, he cleans 1/10 of the patio before lunch and 9/10 of the patio after lunch, it says. So if I add those together, how much did he clean total? Denominator stays the same. 1 plus 9 equals 10. Okay, so if he cleaned 10/10 of the patio, that means he cleaned the entire patio. The whole thing. That's one whole patio, right? If you wanted to draw a picture. 3, 4, 5. Okay, so there's tenths. He did 1/10 before lunch and 9/10 after. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ta-da! Whole patio. He cleaned the entire thing. Okay, so for your solution, he cleaned 10/10 of the patio. Or you could have said he cleaned the whole patio. Either way, okay? Star for showing your work, star for your answer. All right, that's it for that lesson. Next video is going to be for session 3, and that is subtracting fractions. Just a little bit trickier than adding, but still, I'm hoping you guys are feeling good about this one. I hope you feel confident. Have a great day.